Thermochemistry, short notes, enthalpy of reactions, del HR, amount of heat evolved or absorbed during reactions at constant pressure, bond enthalpy, average amount of enthalpy required to dissociate 1 mole gaseous bond into separate gaseous atoms. Del RH is equal to sum of bond enthalpy of gaseous reactant minus sum of bond enthalpy of gaseous product. Enthalpy of formations, del FH may be endothermic or exothermic. Change in enthalpy when 1 mole of a substance is formed from its constituent elements present in the standard state. For elements, del F H0 is equal to 0. For a standard state, del F H0 is equal in bracket O2G is equal to 0. Del F H0 is equal to S8 rhombic is equal to 0. P del F H0 in bracket P4 white is equal to 0. Del F H0 is equal to graphite is equal to 0. Resonance energy, del H0 resonance is equal to del F H0 experimental minus del F H0 calculated is equal to del C H0 calculated minus del C H0 experimental. Enthalpy of combustions, del CH always exothermic. Change in enthalpy when 1 mole of a substance is completely burnt in oxygen. C2H6 gas plus 7/2 O2 gas combine to form 2 CO2 gas plus 3 H2O liquid, del CH in bracket C2H6 gas, del RH0 is equal to summations del CH0 reacts minus summations del CH0 product. Calorific value is equal to del H combustions upon molecular weight. Enthalpy of neutralizations, del H neutral always exothermic. Change in enthalpy when 1 gram equivalent of an acid is completely neutralized by 1 gram equivalent of base in dilute solutions. A strong acid plus a strong base combine to form a salt plus water, del H0 neutral. H plus aqueous plus OH minus aqueous combine to form H2O liquid, del H is equal to minus 13.7 kilocalorie per equations is equal to 57.3 kilojoule per equations in case of weak acid, base or both. Absolute value of del H not n smaller than 13.7 kilocalorie per upon equations and the difference is enthalpy of ionizations of weak species except in case of HF when absolute value of del Hn greater than 13.7 due to hydrations of F minus. Enthalpy of transitions, enthalpy change when 1 moles of one allotropic form changes to another, C graphite to C diamond, del trans H0 is equal to 1.9 kilojoule per mole, H2O liquid to H2O gas, and del vapor H0 del vapor H2O liquid, H2O solid, H2O in solid to H2O liquid, and del fusion H0 H2O in solid, H2O solid to H2O gas, del sublimations H0 H2O S. Enthalpy of atomizations, del H atom always endothermic. Change in enthalpy when 1 mole of gaseous molecules convert into gaseous atoms. Enthalpy of solutions, del H solutions may be endo and exothermic. Change in enthalpy when 1 mole of a substance is dissolved in excess of water so that further dilutions does not involve any heat change. CuSO4 equals to CuSO4 equals del H not solutions. Law of thermochemistry, A to B del RH is equal to x kilojoule per mole, B to A del RH is equal to minus x kilojoule per mole. Lavoisier and Laplace law, Hess law of constant heat summations, A to B del H, C to A del H1, C to B del H2, A to D del H3, D to E del H4, E to B del H5, H del H is equal to del H1 plus del H2, or del H is equal to del H3 plus del H4 plus del H5, or del H is equal to del H1 plus del H2 is equal to del H3 plus del H4 plus del H5. Enthalpy of hydrations, del H hydra always exothermic. Enthalpy change when 1 mole of anhydrous salt combined with the requisite amount of water to form a hydrate salt, CuSO4 solid plus 5H2O liquid combine to form CuSO4 dot 5H2O solid, del H0 hydrations and hydra dot salt and hydra salt. Enthalpy of hydrogenations, del H hydro always exothermic. Enthalpy change during the complete hydrogenations of 1 mole unsaturated organic compound into its the saturated compounds.